Good morning, students. I am Manikant Mishra, Modern English School, New Area. So yesterday we have started laws of chemical combination. So one of the laws of chemical combination that we have already discussed, law of conservation of mass. Today we will talk about the next laws of chemical combination is a law of constant proportion. Law of constant proportion. Now what this law is given by Louis Proust. What is a law of constant proportion? A chemical compound always consists of same element combined together in a definite proportion by mass, irrespective of the method or the source through which it is obtained or prepared. A chemical compound always consists of same element combined together in a definite proportion by mass, irrespective of the method through which it is obtained or prepared. If you take an example of a water, either you take the water from the Nevada, or you take the water from Patna, or you take the water from the Delhi, or you take the water from USA. If you take a pure sample of water from the different places and let it undergo the electrolysis process, in all the sample, first of all, after electrolysis of different samples of pure water, we get only two elements, that is a hydrogen and oxygen. In all the samples of water after electrolysis, we obtain only two elements, that is a hydrogen and oxygen. Not only that, the element is fixed, but the ratio by mass is also fixed. Like in all the sample, the hydrogen and oxygen are in the ratio by their mass is 1:8. 1:8 by mass. So this is what the law of constant proportion. So let us apply this law of constant proportion in solving the numerical. Like one question is here: in an experiment, 2.192 gram of copper oxide was obtained from 1.751 gram of copper. In another experiment, 1.824 gram of copper oxide on reduction gave 1.457 gram of copper, so that the given data illustrates the law of constant proportion. So now to solve, we have two experiments. So I have written in first experiment, in second experiment. In the first experiment, data is mass of copper is given 1.751 gram. Mass of copper oxide is 2.192 gram. Now, mass of oxygen can be obtained by subtracting mass of copper from mass of copper oxide. So, in a copper oxide, this much is the mass of copper and this much is the mass of oxygen. Now, percentage of copper in copper oxide equals to mass of copper by mass of copper oxide into 100. We have mass of copper 1.751 into 100 by mass of copper oxide. So with this, when you solve it, approximately it comes 79.9%. Now percentage of oxygen in copper oxide equals to mass of oxygen by mass of copper oxide into 100. that after solving it comes approximately 20.1%. Now let us come for the second experiment. In second experiment, mass of copper is 1.457, mass of copper oxide 1.824 gram, mass of oxygen we can obtain from mass of copper oxide by subtracting mass of copper. We are getting 0.367 gram. Percentage of copper in copper oxide, mass of copper into 100 by mass of copper oxide. Mass of copper we have 1.457 into 100 by mass of copper oxide, that is 1.824. That comes 79.9%. Percentage of oxygen in copper oxide, mass of oxygen into 100 by mass of copper oxide, which is also equal to 20.1% approximately. So, what I am trying to make you understand, what I am trying to convince you here, in that we are getting the copper and oxygen from copper oxide in two different experiments, but in both the experiment we are getting same percentage of copper, that is a 79.9%. It means in a copper oxide percentage of copper remains constant, and the percentage of oxygen in first experiment we have 20.1, and in second experiment also 20.1. So this reveals that in a compound, a pure chemical compound always consists of the same element combined together in a definite proportion by mass. This is the only law of constant proportion. Rest some more numerical I will give you during your online time, that is from 9 a.m. to 11 a.m. Till then, bye. Thank you.